Okay, so we are looking at sketching by adding ordinates, which is something you've done before, but this time it's got exponential and logarithmic graphs in there. So once again, the key points are the same. You must have two graphs to add, and you need to look for the x-intercepts, because those are when one of them equals 0. That means when you add f to g, then you only get g, because 0 plus g is just g. You look for the intersections, the way they cross over, which is where f equals g, and so therefore when you add them together you get double of one of them. You look for the asymptotes, because usually they are going to be asymptotes of the new graph, and the limits of x as x approaches positive infinity or negative infinity. And the important thing is that domain is where the domain of the additional graph, or the final graph, is the intersection of the two domains of f and g. Right, so here we have function f of x equals 1 on x and g of x equals the square root of x. So our first step is to sketch both of them on the same graph. So if I draw f of x in blue, then I'll have an asymptote here, which is x equals 0, and an asymptote here, which is y equals 0, and the rough shape is the hyperbola, like so. If I do the graph of g of x in green, then that's the square root function, which looks something like this. So it'll just cross like that, and hopefully you can see that the domains are different. So for f of x, the domain is everything along the x-axis except for x equals 0. So you can write that as r backslash curly brace 0. The other way of writing it is just to say x is not allowed to equal 0. Now for g, the domain of g is everything that's positive, including 0. So I really should make that a solid dot there. The domain of g is everything positive, including 0, which is why we have union and then that curly brace there. Or you can say from 0, which has got a square bracket, to infinity. Now you're trying to add up the blue graph with the green graph, and hopefully you can see that there's no green graph on the left, which means that for the addition to exist it has to be in the positive area. So that means the domain of the final graph is going to be all positive. And it looks like this. Domain of f plus g has to be all the positives, excluding 0. That's because 0 is not included in f, so I can't include it in the final result. So here's the final step, the actual addition part. So what you're going to do is I'm going to draw it with a black line, and what I'm going to do is look for the key points. So looking for x-intercepts. So the green graph has an x-intercept right there at 0, 0, which means that it's going to take the value of the blue curve. So the black curve will be somewhere up here, and there will be an asymptote for the black curve as well at the same point as the original. Okay. Now, what you then look for is the intersection points, which is this here. And how do I find this? Well, I'd have to do a little bit of work. I'd say for the intersection point, 1 on x is equal to the square root of x. So what I do to get rid of this square root sign is I have to square both sides. So if I square the left-hand side, I get 1 on x squared. And if I square the right-hand side, I get x. So I then end up with 1 squared, which is 1, over x squared equals x. Now, a little bit of a trick is to multiply by whatever's in the denominator. So I get 1 equals x squared times x, which is x cubed. And the only solution for that is x equals 1. And because I know a little bit more, or I could plug it in actually, y equals 1 on x, and instead of x I could put 1. That would give me 1 on 1, which is 1, so our intersection point is 1, 1. Now, because they intersect at that point, that means that when I measure the height of 1 from the x-axis, I basically have to double that to get to the final point, which is that one there. Right, so after that, if we look at the trends as we go towards the positive infinity in the x, what I'm seeing is that the blue curve starts to get very, very close to 0. So that means that if I was to measure the heights from the x-axis to the blue curve and add them onto the green one, then these x's will start to trend towards the green curve. I'll just do one more down here. Oops, wrong color. So that should have been black. And so if I add that on, it's about there. And hopefully you can see that this side would be starting to drop towards that green curve, which is still rising, but not very fast. Okay, so I'll pencil that in, or draw that in. So that's not very good. Doesn't let me undo either. So it's going to look something like this. Now for the other side, you can hopefully see that as x gets closer and closer to 0, the blue curve gets very, very tall, which means that if I'm taking the height of it and adding it onto the green curve, then it's going to get extremely tall as you get closer and closer to 0. So if I just do an example, then the height of this blue curve is that tall, and if I add it on to the green curve, then I'm actually adding on about that much. And once again, if I look at the blue curve there, then I'm going to take the height from up to there and add that on to the green curve. So if I draw that in, it's about there, sorry, the wobbly line. Now if I add it on to the green curve, it goes up a bit. So my final curve for the f plus g function is the black one, which I draw like that. So here it is with the neat version. We have an asymptote here for the final graph at x equals 0, and it passes through there, and it tends to be toward the green curve on that side and toward the blue curve on that side. So technically speaking, your asymptotes are actually going to be this line as well. So asymptotes are y equals 1 on x if we go towards the 0 here, so that's still an asymptote. And the other asymptote is going to be y equals the square root of x, because it's never going to cross that line either. It's just going to be taller than it just along there. So here's a little bit of further explanation in case you didn't understand the domain before. So here's the x-axis, and we have a 0. And if we cast our mind back to f of x, which is the hyperbola, the function f of x has a domain of everything except for 0, which is why that is an empty circle. So that this is the domain of f, which is r without 0. Now, if we look at g, then we would color code it with a different color, perhaps. And g was the square root of x, so it's allowed to equal 0, which is why that's a filled-in circle. And it goes to the right, so that's the domain of g. Now, the domain of f plus g has to be where they overlap. So that means that this area is where they are having a common domain, but this is not, because 0 is not included in this domain and is included in this one. So if I draw in the overlap area, it's only that part and an empty circle. So that's the domain of f plus g. Done.